All right, guys. We want to find a number that when multiplied by itself, you get a negative number. So what would be a number that we can multiply by itself and get a negative number? So negative 1, well, we'd multiply it by negative 1, giving us positive, because a negative times a negative is a positive. Well, 1 times 1 gives us 1. So we're looking for a number. So let's just imagine some number, when multiplied by itself, gives us negative 1. Because what we're saying is this imaginary number, I, when I multiply it by itself, we should get negative 1. So if I wanted to find I, we could take the square root of both sides. So I is the square root of negative 1. So if we multiplied the square root of negative 1 by itself, we would indeed get a negative number. And interestingly enough, by definition, I is the square root of negative 1. And the reason this is helpful or useful is it gives us the ability to find the square root of a negative. Those no solutions, those no real solution problems have a solution, but the solution contains this imaginary number, I. So if it has no real solutions, well, that's because part of the solution is this imaginary number. Because without it, we can't take the square root of a negative. So if we look at that here, simplifying these expressions, so the square root of negative 25. Well, what we can do to solve this here is we can break this up. Because we can say that this is the same as negative 1 times 25. Because negative 25 is negative 1 times 25. Now, according to our properties of radicals, we can split this up and say that we're taking the square root of negative 1 times 25. What is the square root of 25? 5. Because 5 times 5 gives us 25. Now, we said the square root of negative 1 is what? I. By definition, it is I. So the square root of negative 25 is 5i. Questions on this here? Now, the nice thing is that the graphing calculator will work with I. So we can say 5i squared, and it tells us it is indeed negative 25. So I is the only way we can multiply a number by itself and get a negative. Now the next one we were looking at is the square root of negative 72. Square root of negative 72. Now, guys, let's focus in. Now we can break this up into two parts, or two spots here, because we'd have our negative 1 times 72, or two different components. And again, just like the last one, we can say that this is the square root of negative 1 times the square root of 72. Questions on this so far? So the first thing we can find is the square root of 72. Well, what is the square root of 72? Well, it's probably not going to be a nice number. So the 30xs will reduce radicals for us. So the square root of 72 is 6 square root of 2. 6 square roots of 2. And we said the square root of negative 1 is what? I. So we multiply these back together, we would get 6i square roots of 2. Questions on this here? Questions on anything we've done so far? All right, we can go on and look at C. We have the negative 5 times our square root of negative 9. Just like we've been doing, we could say negative 1 times 9, which would be negative 5 times square root of negative 1 times square root of 9. Well, our square root of negative 1 is what? I. By definition, it is I. Square root of negative 1 by definition is I. Square root of 9, 3. That one simplified nicely, because negative 5 times 3 is negative 15 times I is negative 15i. Because the negative stays there because that negative is attached to the 5 outside the radical, not inside. And then square root of 9 is 3. Our negative 5 times 3 is negative 15. And we have our I from the negative inside the radical. So giving us negative 15i. Questions on this here? Questions on anything we've done so far? We're ready for the next one. Now, as we've seen with some of these here, we can do these in the calculator, especially the 30xs. We just can't type the whole thing in. Because with the next one, negative 4, square root of negative 4, because if I get the calculator out and say square root of negative 4, it gives me a domain error because it cannot take an imaginary number. It can't take the square root of negative 4. So let's look back at this here. Let's back over. Now the negative inside the radical, we know is going to come out as what? It's going to come out as I. Because if I take that negative out as I, what does that leave us with? The square root of 4. Well, what is the square root of 4? 2. So our square root of negative 4 would be 2i. Questions on this here? Now we can look at the next one, square root of negative 12. I can't plug in square root of negative 12, but I do know the negative comes out as I, leaving us with what? The square root of 12. Well, the 30xs will take the square root of 12, which is 2 square root of 3, 2 radical 3. So the square root of 12 is 2 radical 3. What can we say about the square root of negative 12? It would be what? 2i square root of 3. Because that negative with the 12 is going to come out as I. And then the square root of 12 is 2 square root of 3. So we get 2i square root of 3. Questions on how we put that together? We good with these two here? We're ready for the next one. Because the next one we have is what? Negative square root of negative 36. Yes? Well, looking at this here, the negative is going to come out as what? with the 36? I. The negative in the radical is going to come out as I. Now, what does that leave us with? We still have the negative outside the radical, and then we have the square root of 36. So all we need to do is simplify that and put it back with I. Well, negative square root of 36 is negative 6. Because the square root of 36 is 6, we still have that negative outside. So it tells us negative square root of 36 is negative 6. So what would our final answer be here? It would be negative 6 I. Questions on this here? Any questions on any of this so far? Let's look at the last one, number 4. So we have 2 square root of negative 54. Well, this negative is going to come out as what? Negative inside the radical comes out as I. Now that leaves us with what? 2 square root of 54 that we need to reduce. Now the reason we do this is because the 30xs, 2 square root of 54, gives us what? 6 square root of 6. Because it gives us what we need to find our answer. Because if it was just 2 square roots of 54, the answer would be 6 square roots of 6. So with 2 square root of negative 54, our answer is actually what? 6i square roots of, because that negative comes out as I. Questions on this here? You got it? Probably just, again, just working with them a little bit does make it a little bit nicer. Now the graphing calculator can reduce these, but one of the main things we have to make sure is that the mode is correct, because if you look down here at about halfway down, there is a spot where this is blinking that says real. Now if it's set on real, it's only going to work with real numbers, especially when you're taking radicals. So if we told it to take the square root of negative 36 and it was on real, it would tell us it is a domain error. It's not a real number. But what we need it set on is a plus bi, our I, these imaginary, these complex numbers, for it to work. So we do have it there. So negative second square root, negative 36. It tells us it is indeed negative 6i, which is just what we got, yes? Now, the last one we looked at was 2 second square root negative 54. And we got what? 6i square roots of 6. But this gave us a what? Decimal. Because if it doesn't work out to be a nice, perfect square, the graphing calculator will give it in decimal form. We want it in radical form. That's where the 30xs is nice. Questions on this here? All right. Now, powers of I does have an interesting property when we look at the powers. We're multiplying it by itself. So we'll start off with I to the first. Well, we can just say by definition, I to the first is just square root of negative 1. That is I. Okay. Well, doesn't tell us much. The next thing we want to look at is I squared. We're going to multiply I by itself, which is really just saying that we're taking the square root of negative 1 and squaring it. Well, here the square root and square would cancel, telling us that I squared is negative 1. That. Now it'll take a minute, but this will actually have some meaning here. Questions on I or I squared, how we got those values. Be ready for the next one. Well, let's multiply it by I again. I to the third power. Well, I know what I squared is, and I to the third is really just saying that we're taking I squared and multiplying it by I. Well, what did we say the value of I squared is? So what I'm saying is I'm multiplying negative 1 by I, and negative 1 times I is negative I. Okay. All right. Let's keep going. Let's do I to the fourth. Well, I to the fourth is just I to the third times I. There's different ways we could break it down with how we simplify this here. I'm just using the one before it. Because I to the third, we found is negative I. And to get our I to the fourth, we're multiplying it by another I. Questions on this here? Now, negative I times I would be negative I squared. Well, we already know the value of I squared. What's it? So negative 1, which is 1. So I to the fourth simplifies to 1. Okay? Really haven't stumbled across anything yet. Let's do this a few more times. Let's go I to the fifth, which is really just I to the fourth times I. We're just multiplying it by I again. Well, what was I to the fourth? So we're saying we have 1 times I, which is I. Okay. Whatever. Let's look at I to the sixth. Well, I to the sixth would be I to the fifth times I. Well, I to the fifth is just I, because we found that just a second ago, yes? Well, that leaves us with I times I, which is I squared or negative 1. Anybody have a guess at what I to the seventh is going to be? Almost. Because it'd be I to the sixth times I. Well, I to the sixth is negative 1, and negative 1 times I is negative I. What would I to the eighth be? Which would reduce to negative I times I, which is negative I squared, which would be our negative 1, which is, it does keep repeating, because our I to the fifth just ended up reducing to I. Our I to the sixth gave us the same value as I squared, which was negative 1. Our I to the seventh gave us negative I, and our I to the eighth gave us 1. What do we think I to the ninth power would give us? Not quite. It wouldn't be negative 1, because I to the ninth, because we could go through this process, but we went, what are our 4 possible answers for this? Because we have I, negative 1, negative I, 1, yes? And we'd go back to the top. Because here, I to the 8th gave us 1, so I to the ninth should give us I. I to the 8 times I. Well, I to the 8th is 1 times I is indeed I. So I to the 9th would be the same as I to the 5th, which is I. I to the 10th would be negative 1. I to the 11th would be negative I. I to the 12th gets us back to 1. This is the interesting thing with powers of I. It took us a minute to get there, but really with any power of I, we only have one of 4 answers. We either have I, negative 1, negative I, or 1. These are our only 4 possible choices for any power of I. So if we do get an I, this imaginary number to a power greater than 1, we have to simplify it to one of these 4 answers. Now, luckily enough, there is a nice way to do this. I to the nth. The first step in simplifying is taking whatever the exponent is and dividing it by 4. Or take whatever the exponent is and divide it by 4. And what we get from this is going to be a number 0.2 decimals. 2 decimal places, a number 0.2 decimal places. And what we're concerned about is not so much the number, but these 2 decimal points. Because if the decimal is 0.25, the exponent, or this power of I, is going to reduce to I. Now, if the decimal is 0.00, almost, 50, then it's going to reduce to negative 1. If the decimal is 0.75, it reduces to negative I. And if the decimal is 0.00, or there is no decimal, it reduces to 1. Questions on this here so far? Yes. So we did the whole powers multiplying out mainly just to see that the pattern repeats. So we take the power and divide by 4. If the decimal is 0.25, it reduces to I. If the decimal is 0.50 or 0.5, it's negative 1. 0.75 gives us negative I. And 0.00 gives us 1. So if we look at this first one here, I to the 27th power. Well, what do we need to do first? We need to take the 27 and divide it by 4. So we can say 27 divided by 4 is 6.75. Yes. Now we don't care about the 6. All the 6 tells us is that we went through this cycle of 4 values 6 times. Yes. 0.75 corresponds to negative I, which is telling us that I to the 27th is equal to negative I. Questions on this here? Questions? Questions all? Okay. Let's look at the next one, I to the 34th. So we're going to take 34 and divide it by 4. Again. 34 divided by 4 is 8.5. So we don't need the 8, but the 0.50 tells us this reduces to negative 1. So our I to the 34th power is the same as negative 1. Our next one is going to be I to the 47th power. Here we're going to take the 47 and divide it by 4. 47 divided by 4 is 11.75. Again, not concerned with the 11 because we're needing the decimal place to tell us which one we have. And the 0.75 tells us that this is negative I. Let's look at the next one, I to the 65th. For this one here, we would take 65 and divide it by 4. And 65 divided by 4 is 16.25. Yes. And the 0.25 tells us that this reduces to I. Questions on this here? Questions on anything we've done so far? Last but not least of the set here, we have 1040. And we're going to divide it by 4. $10.40 divided by 4 is 260. If we type it in the calculator, we'll tell it's 260, and it would be 1. Because even though the decimal is not given to us, it's understood to be what? 0, 0, 0. Yes. Questions on how we found any of these here? Now, I to the 34th power. We could do this in the graphing calculator. Now, to get I, we're going to go second decimal place, exponent 34. And it tells us I to the 34th power is negative 1. I think it was actually, yeah, and that's what we got, yes? The second one was asking for I to the 74th, yes? $47, a little different. 47th power is negative I. That still agrees with what we got, yes? So they work about the same. The next one is I to the, trying to read upside down, 65th. Is indeed I, yes? So these aren't bad. And the last one was what? I to the 1040, yes? And what did we get for this value here? For the last one? 1, yes? And the calculator agrees that it is 1. E to the negative 12i. So what it gave us is this here. 1 plus 4e negative 12i. Now, what this is telling us here is that we have 4e is just for another way to write a multiple of 10, or multiplying by 10. And the number after e is the exponent attached to it. The I is not a part of the exponent. So what we're saying is that we have 4 times 10 to the negative 12th. Now, for us, we still have the 1 plus. Now, 4 times 10 to the negative 12th. What that means is that we're going to take the decimal place that's right after 4, and we're going to move it 12 places to the left, which would give us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This here. Which for us here, this number, almost got it. This number here, for all cases and purposes, is 0. It's just a pixel error in it calculating, because when it gets numbers too big, it gives us a pixel error, an error in its calculations. Essentially, it's trying to graph it to be able to approximate these powers of I, or find the values of I. So really, that there is 0 telling us that it is indeed 1. Does that make sense? So this here works, the graphing calculator works, but when we get with these bigger powers of I, we get this error, this approximation error, and we have to interpret it. Well, it's just as easy to take the exponent and divide by 4 and get to the answer as it is to just type it in. Because if the numbers are small, the graphing calculator will do it just fine. If they get a little too big, then we've got to interpret what it means. Okay? We're ready for the next part. Addition, subtraction. You don't have to write all that down because it'll make sense when we start doing these here. They're actually kind of nice. To add or subtract two complex numbers, add the real parts together and then add the complex parts together, or subtract. So let's look at the first one here. 8 minus I, the quantity 8 minus I, plus the quantity 5 plus 4I. Well, the 8 minus I, there's nothing in front of the parentheses besides our positive 1, so we can drop the parentheses. The same thing is true with our 5 plus 4I. We can just drop the parentheses and we get this here. Questions on this so far? Now we're going to rearrange it and move it around just a little bit so we get our real parts together, the real numbers, 8 and 5. So we're saying 8 plus 5. And then our negative I plus 4I. Questions on this so far? Now I did this here mainly just so that we can see which numbers are the real parts or the parts that correspond to each other and our imaginary parts. Now the first thing we need to do is 8 plus 5. What is 8 plus 5? 13. Negative I plus 4I. 4I minus I. And it would be positive, so we would have plus 3I. Now, since 13 and 3I are not like terms, that's our final answer. So for the most part, we can treat I the same way we do a variable, except if it gets a power greater than 1, we've got to reduce it to our I, negative 1, negative I, or 1. But addition and subtraction, it almost works the exact same way as a variable. We can add or subtract them like terms. Questions on this here? We're ready for the next one. 7 minus 6I minus 3 minus 6I. Well, our 7 minus 6I stays the same. But for our second set of parentheses, we have to distribute this negative through because we are subtracting. It's going to turn our 3 from positive to negative, and it's going to turn our negative 6I from negative to positive. Questions on this so far? What are our like terms? 7 and negative 3, yes? What is 7 minus 3? 4, okay? Negative 6I plus 6I. What is negative 6I plus 6I? It is 0. So our answer is what? 4. That's it. Be ready for the next one. 13 minus 2 plus 7i plus 5i. So we still have the 13, but we do need to distribute this negative through this middle set of parentheses. And that's going to turn our 2 from positive to negative, our 7i from positive to negative 7i plus 5i. Now this is kind of nice because our like terms are next to each other. So 13 minus 2 is what? 13 minus 2 would be 11. Negative 7i plus 5i. Yes. Because we can say negative 7 plus 5, which is negative 2. Because with our addition and subtraction, we can treat it just like a variable. Even when we do multiplication, because I times I would be I squared, we can still treat it the same way we do a variable. The only big difference is that when we start talking about powers, when it gets bigger than 1, we do have to reduce it. Two plus 9i plus 11 minus I. Well, here we can drop the parentheses. So it's telling us that we have 2 plus 9i plus 11 minus I. Our like terms, 2 and 11. 2 plus 11 is what? 13. I minus I is plus 8i. So our 2 plus 9i plus 11 minus I is 13 plus 8i. Questions on this here? Any questions on this so far? Well, this is technically missing a parentheses. Now the question is, could we type this in the graphing calculator? Because we've been able to do it for the most part so far. Well, let's see. 13 plus 4i minus 8 plus 4i is 5. So yes. With this here, we can type this straight in. Even with the next one, 16 minus the quantity, 13 plus 6i, in quantity plus 8i, is 3 plus 2i. Questions on this here? We'll stop. We'll finish this.